Hello, I'm Amber Uper, and this is Mini Lathe Amateur. The reason I call it Mini Lathe Amateur is because I have no formal training or school for running these things, these machine tools. I'm just an amateur. I'm learning as I go. But anyway, for this episode, I want to talk to you about my railroad wheel project. I haven't worked on this thing, well, all summer. It's been since last spring, the last time I did anything with this project. And what I'm in the process of doing now is making all of the center holes in the wheel, the axle hole, all the same. So that when I cut the axles, I have a much better ability to cut the axles the same. Now, I'm not going to be boring these out with a boring tool. I'll be drilling them out with a drill bit. If I wanted a really smooth finish, I would need to get a reamer of the appropriate size, but I don't need them that smooth because I'm going to have a light interference fit or maybe a very tight slip fit, and I'll use Loctite to hold them in position. So if it's a little rough in the hole because of the drill bit, that's fine because it's some place for the Loctite to go. So anyway, let me move the camera up close so you can see what I'm doing, and I'll show you the process that I'm using. So you can see I have a railroad wheel clamped into my faceplate here. I took the chuck out and put the faceplate on because it's much easier to do with the faceplate. I really can't do this with the chuck because I have no way to hold the wheel. The chuck is not big enough for the size of the wheel. So I had to do one first to make sure that this was going to work before I made a video about it. So the first thing I have to do, if I can find the right wrench, is to have to undo the clamps here, get this wheel off. I bought new clamps for this faceplate that are made specifically for the faceplate, for faceplates in general. Can be used on any of them, not just this one, but you know. So these have an interesting way to clamp because they have two holes in them. You've got the hole in the back. Let's see if you can see this. I'll just take one of them out. Okay, so they have, let's see, there we go. Move it over there. All right. So now you can see the slot in the clamp, and then there's also a regular threaded hole, which yeah, you can see the bolt there, and the bolt goes into the hole, and you can adjust the length of the bolt where it sticks out to adjust for the thickness of the piece that you're going to clamp down, so you get the clamps almost flat. You want them pretty close to flat here. So since I got this one out, that one's done. Let's put another one in. First, let me put this back in. These have to go up like this. Okay, now for the first part of this, I need to use my live center. Live center just means that the point turns so that it'll rotate with the part that it's holding. Let's put that in. I probably should clean that. If this isn't real clean, it could introduce it could introduce error in the center of the thing so that it's off center. For lack of more scientific way to explain it. Alright, so now I have to take this right up close. So I can take this up close, and then I tighten my clamp here that holds the tailstock in place. I use a long nut on the bolt instead of, I haven't modified that for quick clamping or whatever. There's videos on YouTube where you can see how they do that. Anyway, the next step is to take the wheel, and I put it on backwards like this, because if you put it on this way, you're clamping on the face of the wheel, and I'd rather clamp on the back of the wheel. So we'll put it in this way. And then I'm going to run this out. Let's see here. Get that a little closer. Well, it doesn't matter now, does it? I already clamped it down. So the idea here is to use the live center to center the wheel on the faceplate, so that when you run the drill through, it's as centered as it's going to get. Okay, now you got to make sure that this bolt is not in the hole, because it'll do that. It'll tip. So you got to get it up above the hole on the edge, like that. And then tighten it on. I tighten them all hand tight first. And it helps to make sure, once you get these tight, it helps to make sure that the thing will turn without any of the bolts hitting the bed of the lathe, because it's pretty close. Alright, so now just going to tighten these up a little bit. Oh, I see what we got here. This clamp needs to go out. Oh, it was a little close. Okay, so that's all. There. Make sure they're tight. This one's awfully close also. Oh, I see what's going on with this one. The bolt moved in the slot on the faceplate, so that's another thing you have to look at. Okay. Alright, so they're all tight. So now that I got it centered as well as I'm going to be able to get it centered, they don't have to be perfect, but they should be close. Otherwise your wheels won't run, your wheels will run out of round, I guess you'd say, if the hole's not centered in the wheel. And since I cut the wheels, since I cut the tread on the wheel with the hole already drilled, the initial hole already drilled, and then an arbor holding it that way, the wheel should be centered to the hole. The rim should be centered to the hole. So now we're going to back this off. Now I have to move the tailstock back, because the drill bit is a lot longer than this live center is. So we go way back. Okay. I'm going to crank that all the way back so it knocks the live center out. There. Now, the next thing I've got to use is my drill bit. This has the tailstock MT2 taper and a 1/2 inch chuck, or actually that's a 3/8 inch chuck on here. And it's screwed onto the arbor You can buy them with the threads already on them, so you don't have to mess with them. Threads for the various different chucks. This is a Jacobs chuck. It's just an old Jacobs chuck off of a drill. It's fairly centered, close enough for this purpose. It's not a high precision chuck, but it's close enough for this. So I got to put that in the tailstock. Bring the tailstock out far enough. There. So now that's in. Now we'll bring the drill bit up close. Okay. Got to tighten up the tailstock now. That's about as tight as it's going to get. And that's not hitting anything. So, we'll turn it on. I just run it at a low RPM for this purpose. I'm going to get on the other side of the camera here. And you can see what's going on. And I just slowly crank the... boy, that thing's out of... Alright, let's try this. You know, like I said, this drill chuck is not very accurate. It's a much better centered. So there it is. That's drilled out. I wouldn't call it perfect because apparently my drill chuck doesn't hold the drill quite centered. I'm going to probably have to buy a new drill chuck that has better precision than this thing does. But for this purpose, it'll do the job. Take the drill chuck out. Let's see, I can't take the chuck out until I move the tailstock back because of the links. That's basically all there is to this operation.